Hello guys, welcome to Prof 1 YouTube channel. On this video we are going to look at this question, that is, replace the force and a couple movement system acting on the overhang beam by a resultant force and couple movement at point A. But before we start with this tutorial, I want to brief you more on my YouTube channel. Now my YouTube channel is based on tutorials, but every tutorial that I release one relax with nature, which will enhance your understanding. You need to take time and have time with nature. Thank you. So let's start with the tutorial. And please, if you've not subscribed to my channel, please check the subscription button and hit the button. Thank you. So now, with this question, we are asked to find the resultant force and also the couple movement at point A. This is point A. So what you need to do now is we try resolving this force in x and y component and resolving this force also in x and y component. After then, we add the forces, the s component and the y component, and we find the magnitude and also the direction or the sense. Let's start. So with this force, note that this force is coming to the point. Now note, when resolving forces, make sure the forces are away from the point. So we have a principle which is called the principle of transmissibility. That principle can help you transfer the force to another direction. Now let's handle this force. So we have the s component. Now this force is coming down. We are using principle of transmissibility, so this arrow can come here using principle of what? Transmissibility. And here is 30 degrees. So with vertically opposite angle, automatically here becomes 30 degrees. But note, we only works with the angle which is made with a positive or the negative x-axis. So if here is 30 degrees, automatically here becomes 60 degrees. So we are working with this angle. So when resolving this force in s component, we're going to get, that is, since x is in negative quadrant, you're going to get negative 30 kilonewton cos 60. That is this force, kilonewton cos 60, which will give us negative 15 kilonewton. So that is the fx for this force. When we resolve it in a y component, since the y component is also negative, you're going to have negative 30 kilonewton sin 60, which will give you negative 25.980 kilonewton. So we've resolved this force in the x and y component. Let's check this force. Now with this force, this is the s component, and this force, using principle of transmissibility, we can use it and it will come down here. So actually we can transfer the force. This is the force here now. But now this angle is making with this, but normally we work with the angle that is made with the positive x-axis. So actually we are going to use a different diagram. That is, you draw a different triangle. This is a hypotenuse. So if you are drawing a different triangle, you are going to get something like this. That is a different triangle, which is this. So automatically the hypotenuse is 13. We have the x component to be 5 and we have the y to be 12. So when we do that correctly, we are going to get the fx to be equal to 26 kilonewton times 5 over 13, because cos, that is 26 kilonewton times cos, which is adjacent. This is this one, adjacent over hypotenuse. When you do that correctly, you're going to get 10 kilonewton. You do the same for the y component, and note the s component is positive and the y component is negative. So what you do now is the fy is equal to negative 26 kilonewton times, it is sine opposite over hypotenuse, so it is 12 over 13, which will give you negative 24 kilonewton. So we have both forces. What you need to do now is you're going to add both forces. So this plus this will give you 5 kilonewton, and you add this, you give you 49.98 kilonewton. After doing that, you find the resultant, that is square root of, that is 5 kilonewton squared, because when you add this, you're going to get 5 kilonewton, and when you add this, you're going to get negative, but well, this is, you can put negative here. When you square it, you get the same. So when you do that correctly, you're going to get the resultant force. That is the resultant force at A. That's the resultant force. We are resolving these forces. We have 50.2 kilonewton. So we've resolved the forces. So we added these two to get this and that. And when you do that correctly, you're going to get 50.2 kilonewton. Now we need to find the sense or the direction. That is the sense. With the sense, you're going to get theta is equal to tan inverse of this, the y component over the s component, which will give you 84.3 kilonewton. 84.3 newton. 84.3 degrees. This is, we ignore the negative because when finding the angle, you ignore the negative. The negative indicates that, or it shows you the direction of the force. Now after that, we are supposed to find the couple moment at A. So we finding the couple moment at A, we are taking our anticlockwise to be positive. So our anticlockwise is positive. Now this is what we get. That is negative 45 kilonewton meter. This force is moving in the the clockwise direction. It is opposite my direction, so it means this will be negative. Now when we take the 25.98 direction, this is the y, this is the negative y component. It's going to move this side, which is also anti-clockwise, and the distance is 2 meters. That's why we have this, plus 15 kilonewton. 50 kilonewton is now here. If it's here and it's moving at A, it will move in the anti-clockwise direction to A, which is, the distance is 0.3 meters. So we have 15 kilonewton times 0.3 meters. Now we have the 10 kilonewton, which is this 10 kilonewton here, and when it's moving to A, it will move in the clockwise direction, so it will be negative. That's why we had negative here, time the distance it's making. So when you move, the distance is, this distance is 0.3, and we have our force, which is the y component. Also to move in the clockwise direction, and the distance is 2 meters plus 1 plus 1 plus 2, which will give you 6 meters. And when you do that correctly, you're going to get the moment at A, or the couple moment at A, be negative 239.46 kilonewton meter. This can be written as the moment being equal to 239.46 kilonewton meter clockwise because of this negative sign. So this is indicating that this force is moving, or the movement of this is moving in the clockwise direction. Thank you very much for watching.